Good day, everyone. Today, we will present experiment number 9 entitled Compressive Strength of Concrete. The main objective of this experiment is to determine the compressive strength of concrete. This test is important because compressive strength is one of the most essential properties of concrete used in construction and civil engineering projects. In this experiment, we aim to learn how to properly determine the compressive strength of concrete using standard laboratory procedures. We also aim to understand the importance of compressive strength in the civil engineering field, especially in ensuring that structures are safe, stable, and durable. Lastly, this activity helped us apply practical techniques and skills related to testing concrete, which can be useful in future professional engineering practice. Before discussing the testing process, it is important to understand what compressive strength means. Compressive strength refers to the ability of concrete to resist heavy loads or pressure without breaking or failing. Since concrete is commonly used in buildings, bridges, pavements, and other structures, it is necessary to know if the material is strong enough to support the loads applied to it over time. The experiment focused on observing how concrete behaves under compressive stress. The results obtained from the testing process provided valuable information about the strength and performance of concrete. Stronger concrete usually has higher compressive strength, which means it can safely support heavier loads and resist structural failure. For this experiment, the main resources used were concrete samples and a universal testing machine, also known as a UTM. The concrete samples were prepared and cured for specific periods before testing. The UTM was used to apply compressive force on the concrete specimens until failure occurred. The procedure of the experiment was simple and systematic. First, the concrete samples were prepared properly. After preparation and curing, all samples were tested at TERM's concrete testing laboratory using the universal testing machine. During the testing process, pressure was gradually applied to each concrete specimen until cracks formed and failure occurred. The maximum load carried by each sample was then recorded and used to compute the compressive strength. Based on the results gathered from the experiment, we were able to determine the compressive strength of the concrete samples at 7 days, 21 days, and 28 days of curing. At 7 days, the average compressive stress obtained was 8.54 megapascals or MPa. At 21 days, the average compressive stress increased to 11.50 MPa. Finally, at 28 days, the average compressive stress reached 15.21 MPa. The results clearly showed that the compressive strength of concrete increased as the curing period became longer. This demonstrates that proper curing plays an important role in the continuous development of concrete strength. In conclusion, this experiment successfully demonstrated the process of determining the compressive strength of concrete using a universal testing machine. The activity also emphasized the importance of curing time in improving the strength and quality of concrete. Through this experiment, we gained knowledge and practical experience that are relevant and useful in the field of civil engineering. Thank you for listening.